All right, quadratic functions. So we are going to start with the equation of a quadratic function. A function is quadratic if its equation can be expressed in the form y equals ax squared plus bx plus c. A, b, and c are constants or real numbers, and a is not equal to 0. So why is a not 0? Or what would be bad if a were 0? It wouldn't be a quadratic, right? We wouldn't have that second power. Okay, which of the following are quadratic functions? So, is this quadratic?
Yes.
Yes. Is this quadratic?
No.
Why not?
Because it's cube.
It's got a cube. Is this quadratic?
Yes.
Yes. Because if we multiply this out, then we will get a quadratic function. So if you're not sure if a function is quadratic, right, you just multiply this out, and you'll see that, yep, you get a quadratic. Okay, this has an x squared. Is it quadratic?
No.
No. Why not? It's on the bottom, right? It's actually, so it's called a rational function. And this has an x squared, but it's not quadratic because you got the root x, okay? So we can have an x squared term, we can have an x term, we can have no x term. We can have a constant term or no constant term, but we can't have like a root x. Graph of a quadratic function. The graph of every quadratic function is a curve called a parabola. The point where the parabola changes direction is called the vertex. Right, so if you're never sure, just look down a little, and the odds are pretty good that the answer will be there. The parabola may open down, in which the vertex will be a, so what do we call this point? Maximum point. Or the parabola may open up, in which the vertex will be a minimum point. The vertex can be found using the TI-83 calculator by selecting second count and selecting
3 minimums.
right. So 3, which is minimum, or 4, maximum. Okay, and then the calculator is going to ask you for a left bound or right bound, so you just got to move your cursor to the left of the minimum or maximum, to the right of the minimum or maximum, and then it asks for a guess, and you just go somewhere close. Axis of symmetry. The parabola is symmetrical about the axis of symmetry, which is a what kind of line? Vertical line. There you go. A vertical line that passes through the vertex. If the vertex of a parabola is PQ, then the equation of the axis of symmetry is? Okay, so being an equation, it's got to have an equals, and being a vertical line, it's going to be of the form x equals. Okay. So this is the point PQ. The axis of symmetry is a line. Okay. Lines have equations, right? Vertical lines have equations of the form x equals, so it's x is equal to the x-coordinate of the vertex, which is p. The domain of all quadratic functions is? So when you think domain, just think, is there any number that you can't give a quadratic function? Why not? Can you square 0?
No.
Really? Because I can't. I can just multiply it by itself.
Yeah, but it's 0.
Yeah. What's 0 times 0?
0.
So is that bad?
Yes.
Why is that bad?
Yes.
When do we have problems with domains, right? When we have a square root because we can't do the square root of a negative, right? Or when we have something on the bottom, because then that can't be 0 because you can't divide by 0. You can multiply by 0, you can add 0 to stuff, you can't divide by 0. Now, quadratics don't have any division in them, right? So, domain of all quadratic functions is x belongs to the real. You can give it any real number, it will give you back another real number. The range of a quadratic will depend on whether it opens up or down. If the vertex is PQ and it opens down, then what's the range? So PQ, it opens down, the range is? Y is less than or equal to Q. Opens down, has a maximum, right? It has a maximum, and it's going to be, the range will be Y is less than or equal to. Okay, what if it opens up? What's the range?
Y is greater than or equal to Q.
Yeah, Y is greater than or equal to Q. Okay, if it opens up, it has a minimum, meaning that all Y values must be greater than or equal to the Y coordinate of the vertex. If it opens down, it has a maximum, which means that all Y values must be less than or equal to the Y coordinate of the vertex. Y-intercept is the Y coordinate of the point where the graph intersects the Y-axis. At this point, the value of the X coordinate is always 0. Okay? Just remember, always think that. The Y-intercept occurs when X equals 0. The Y-intercept can be found by using the TI-83 calculator by selecting second calc value and then typing X equals 0, right? We want X to be 0. The equation of a quadratic function is Y equals AX squared plus BX plus C. Then the Y-intercept is equal to? What's 0 squared? What's B times 0? What's A times 0? What's 0 plus C? Okay. So just think about it, right? Y-intercept occurs when X is 0, which means you're going to wipe out the X squared term, right? AX squared, that'll just be 0. You're going to wipe out the BX term, again, that's going to be 0. You're just going to be left with C. So we look at this, right? If we need to do Y-intercept, we just say, oh, it's just going to be the constant term, right? It's just going to be the C value. So this point up here is 0, comma, C. Okay, C. Switching to Spanish now, C. X-intercept. The X-intercept is the X coordinate. So X-intercepts are just numbers. They're not points, right? It's just a number. So the you say the X-intercept is 5. You don't say the X-intercept is 5, comma 0. You could say the point where the graph crosses the x-axis is 5, comma 0, right? When we talk X-intercept, we're just talking X coordinate. Where the graph intersects the x-axis, right? Surprise, yeah. At these points, so it could be point or points, the value of the y coordinate is always 0, right? There's no up, down. Remember, y is up or down. These points are no up, down. The x-intercepts are also called the zeros of the function, right? The zeros as in the value of x that will make the function equal to 0. X-intercepts can also be, or can be found using the TI. The x-intercept can be found using the TI is by what? Anyway, is by selecting second calc 0. If you do that, it's going to ask you for a left bound and a right bound and a guess. The way that I like to do it is to enter y2 is equal to 0 and then do it using second calc and intersect. Okay? And we'll practice all of this. So that's a point x comma 0, right? The y value there is 0. Examples. For each function, determine the following. Round answers to the nearest tenth if necessary. So we have x squared minus 6x plus 8. Okay, so the first thing we do is get out our graphing calculators. I'm going to just pause. Okay, so graphing calculator out. We're going to go to y equals. that was like a second way. Wait, why are you doing that? Okay, something's locked up here. Y, there we go. Y equals, if there's anything in there from before, just clear it out. Okay, so x squared, so here's your x. That's the squared down there, right? Because squared is used a lot. When you do that, it'll actually pop back down onto the line. If you do cubed or something, it's going to stay up there. So we want minus 6x plus 8. Okay, best way to do any graph is just to go zoom 6, do a standard zoom. That gives you negative 10 to 10. Negative 10 to 10 on the x and negative 10 to 10 on the y. Okay, so we pretty much have that kind of as a grid. So this is pretty sketchable here. So we're coming down here like this and then going up, right? So there's a little sketch of the graph. Coordinates of the vertex. So how do we find the vertex on this graph? The minimum, right? Okay, so we go second calc, number 3 is minimum. Okay, left boundary. So I just need to be to the left of this. I'm just going to arrow down a bit. So, okay, so that's the left boundary. Then I want a right boundary, which means I need to go past this and back up again. Okay, so it's going to go up a little bit. Right boundary. And then I want to guess, which means I'm going to head down to about where I think the minimum is, or pretty close to it. And hit enter. And it says minimum is at 3. Now I got these 0.000017, so you're just going to kind of ignore that decimal bit. So it really is at 3, negative 1. Okay? So if you plug a 3 into the equation, you're going to get 9 minus 15, which, where's that, 3? Yeah. So you're going to get 9 minus 3 minus 18, which would be negative 9 plus 8 is negative 1. Okay? So the vertex is at 3, negative 1. Being a vertex, it's got coordinates. It's a point, so it needs parentheses around it. Right? That's how we indicate that it's a point. What's the equation of the axis of symmetry? X equals 3. So remember, it's an equation, it needs an equal sign. It's a vertical line. It's the vertical line passing through, and it's equal to the x coordinate of the vertex, so x equals 3. What's the domain for this? Yeah, so for all quadratics, domain is always x belongs to the reals. How about the range? So we got a minimum or maximum going on here.
Y is greater than or equal to negative 1.
Yeah, y is greater than or equal to negative 1. What are the x-intercepts? Okay, so looking at the grid, it looks like the x-intercept is 2 and 4. Okay, so we're looking at the now, here's one way you can see if it really is 2 or 4. If you go into second function graph, you go into the table, then you can see when x is 2, y is 0, when x is 4, y is 0. Okay. So that's a way to verify that, yeah, they really are, without going into all of this, you know, second function calc, 0, etc., right? Okay. We're going to have to do that for another one where the x and y intercepts won't be nice numbers. But here, you know, from the graph, it looks like it's 2 and 4, right? How do I make sure? Go into the table and say when x is 2, y is 0, when x is 4. So the x-intercept or intercepts are 2, 4. Do not put parentheses around that, right? If you do, it'll become the point 2, 4. Okay? We don't want that. We just want 2 and 4. Might be better to write it as just saying 2 and 4. Okay? That way, if you put the comma around, you're not tempted later on the test to go back and then change it. What's the y-intercept? Positive 8. Okay? So two ways we could do that. We could do a second calc 0. I mean, let's run that just because it won't take long. So second calc value, right, for x, put in a 0 for x, get out an 8. Right? Now we already know that actually from the equation. What's the y-intercept for this one? 15. Okay, let's just pop down to the bottom. We can do the 15. What are the x-intercepts? Okay, no idea yet, right? So we're going to go back. So I'm going to go to y equals. I'm not going to clear this out. I'm just going to edit it. So I'm just going to go second insert and put in a -5 in front of the x squared. Instead of -6, whoops, I don't want minus, I want plus 8x plus 15. Okay. So you can edit it. You could just hit clear on that and just enter -5x squared plus 8x plus 15. Okay. And now, I know the y-intercept is at 15, but I'm just going to hit graph. Let's see what this looks like. Okay, so I can say, you know what, I'm going to change the window to kind of, to find the x-intercept. We got -1, it says 1, 2, 3. So I'm going to go like -4 to 4. So window. I'm going to say -4 to 4 by 1s. -10 is fine. I'm going to go up to 20. And I'm going to see what that looks like. Okay, do we get the vertex? It's not bad. That's where we go. -10 to 20. I'm going to change that to 2s though, just because it was a little too many ticks there on the window. So I change my Y scale to 2. The graph. Okay, so we know it's going through here at 15, and what does it look like? So it looks like that looks like -1, but I can't be 100% sure. And that looks like what? 1, 2, somewhere between 2 and 3. 1, 2, 3. That's a 15. Okay, coordinates of the vertex. How do we find it? Okay, so we're going to go second calc max. Second calc number 4 is maximum. Okay, left bound. That's good enough. Somewhere to the left. Right bound, just got to get over the hill here, a maximum. And then guess. So we have 0.799999999. What am I going to call that? 0.8 and 18.2. Right? It says round answers to the nearest tenth if necessary. The 0.79999 really is 0.8, right? Okay. Remember, your calculator is just using, it's using a mathematical method to find that, so it's not necessarily going to be exact. Just like on there, we had 3.00000, and that's still a 3. What's the equation of the axis of symmetry? So it's always of the form x equals 0.8. What's the domain for every quadratic function ever? X belongs to the real. Now, domains may change based on context, right? So if we have a parabola that's modeling something, like a stone being thrown or a ball being kicked or something like that, then we may set a domain for that, right? So it only makes sense to look at this from like a time of 0 seconds to 5 seconds. Okay, and again, we may set a range also. And what's this range? Okay, we've got a maximum point, so all the y values are going to be less than or equal to 18.2. X-intercepts. So that looks like -1. All right, so I could go second table, and I could see -1, it's not it. Okay? So I'll do it both ways, just to demonstrate both ways. Go back to the graph. So let's go second calc number 2 is 0. Okay, left bound, so I'm going to have to trace this down forever. One hit at a time. Okay. So when you do left bound, in this case, because it's going up, we need to be below the axis. So I have a negative value. Right bound, I'm going to need to be up above the axis, so just go up a little bit. And for the guess, whoops. And we have -1.1. Okay, so x, oh, sorry, just write it down. So -1.1 and for the other one, I'll do it the other way. So another way to do it is you go to y equals, you go to y2, you set that equal to 0. Graph that. Okay. Now if your calculator is black and white, you're not going to see that other line drawn. It's just going to be drawn on top of the axis. But it's there. So now we go second calc. And I could do number 5, which is an intersect. So what I need to do is just move to this point. Now, I can either go up and over. See, I'm on y1 right now. It's indicating y1. First curve, everything's blue for y1. I'm just going to kick it down to the red curve, because that way I just have to move over along the red line. So my first curve is now the red curve. I'm just following this straight line to get. So when I do an intersect, I always move to the point of intersection. Or as close as I can get. Your calculator is asking you first curve. So in this case, yeah, red curve is good enough for first curve. Second curve is going to jump to the other curve. We only have 2 curves, right? Second curve, this guy, and then a guess. See, by having moved there, I don't have to move again. So just hit enter, and we get 2.707, so 2.7. Okay, and the y-intercept, we can do second calc value 0, or we can just look at the equation and say, hey, here it is. It's just 15. Okay, any questions on that first bit? Okay, so just to review, we've looked at parabolas, right? We've looked at a quadratic. They can open up or down. The graph is a parabola. It's got a vertex, which is where it changes direction from either going down to going up or from going up to going down. That vertex is where a vertical line called the Axis of Symmetry runs through the x-coordinate of the vertex. That's a line you could fold the parabola on, right? One half would fold on top of the other. Domain for all quadratics is real numbers. The range depends on whether it opens up or down. If it opens up, it's greater than or equal to the y-coordinate of the vertex. Opens down, it's less than or equal to the y-coordinate of the vertex. Okay, graphs of quadratic functions. Actually, I think I need to save this for that. Just saying that because somebody wrote on it and saved it with writing on it, and so it was just. All right, graphing a quadratic function using a table of values. Complete the table of values below for y equals x squared plus 5x plus 3 and plot those points on the grid shown. Okay, so we just plug in a -4, square that. -4 quantity squared is 16. 5 times -4 will be -20. That'll give me 16 minus 20, which is -4 plus 3 is -1. -3 squared is 9 minus 15 will be -6. Plus 3 will be -3. -2 squared is 4 minus 10 is -6. Plus 3 is -3. -1 squared is 1. Minus 5 is -4. Plus 3 is -1. You got a 0 in there, you're just going to get out 3, right? Put a 1 in there, we get 1 plus 5 is 6, plus 3 is 9. Okay, so substituting values in and working them out, right? You can use your calculator to do that. You can also put the equation in your calculator and then just go into the table and go up and look in the table for those values. Okay, I showed that the other day. And now we want to plot this. So negative 4, negative 1. Negative 3, negative 3. Negative 2, negative 3. Negative 1, negative 1. 0, 3. And 1, 9. Okay, what shape should it be? Should be a parabola. Parabola. Plot other points using symmetry. Okay, so where's the vertex? So what's the x-coordinate of the vertex here, do you think? Just looking at this. Yeah, it's going to be in between these two guys, right? So we can see that on either side, if these are 1s, these guys are at 3, so what's at negative 5? It's going to be positive 3, right? And at negative 6, we had to be positive 9, right? That way we're symmetrical about that center, right? Which is going to lie between any 2 points on a horizontal line, okay? And we'll get more into that as we go through this. So plot other points on the graph using symmetry. So we did that. We did that by actually kind of plotting our axis of symmetry, right? X equals negative 2.5. Plot other points, done. Yeah, we have a nice parabola. Okay, now I don't know where the vertex is, right? I don't know how low it goes. Imagine some horizontal lines passing through the graph of the parabola. What do the y values of the points on a horizontal line have in common? Okay. So horizontal line. What can you say about these y values? They're the same. Okay? They are the same. And I'm just going to remove those 3 red lines. Okay, so they are the same. Y values of points on a horizontal line are the same. How could you use 2 points on one of the horizontal lines to find the equation of the axis of symmetry of the parabola? Okay, well, we did that, right? We just said what's halfway between here and here, right? How do we go what's halfway between here and here? Or here and here? So how do you get halfway between 2 numbers? What do you do with the numbers? Add them and divide by 2. You find the average, right? The average value. So if you have 2 numbers on a horizontal line, 2 points on a horizontal line, you know that because of symmetry, that the axis of symmetry has to be halfway between them. Right? Halfway between 2 numbers is the average of the 2 numbers. Okay, so how could we use 2 points on a horizontal line? Find the x value halfway between them. Halfway between them. Okay, so average them. Okay, so you're just going to average the 2 numbers. Yes, the hashtag actually stands for number. It used to be a number sign. That was a hashtag. So don't average the 2 hashtags. Average the 2 numbers. Find the axis of symmetry of the parabola above using 2 points on a horizontal line passing through the parabola. Okay, so from the table of values, we had 2 points. What were the 2 points? from the table of values, we had -3 and -2. So from table of values, okay, we had x equals -2 and x equals -3. Right? So we want okay, so if I've got a table of values, I look in the table of values and I say, hey, these y values are the same. Right? If the y values are the same, then I say, then I could draw a horizontal line, right? Horizontal line, just flat line across. Think of the horizon. Look out the window, you see the horizon? Not really. See trees and stuff. Okay, so a horizontal line. What's another pair of numbers we could use? We could use -5 and 0, right? We could use the points -5, 3, and 0, 3. Right? So remember, the idea is find 2 points whose y coordinates are the same. So -5, 3, and 0, 3. And then average the x values. So -5 plus 0 over 2 is -5 halves, or -2.5. Okay, and that'll give us the equation of the axis of symmetry, which will then give us the x value, right, the x coordinate of the vertex. Right? So 2 points on a horizontal line, average the x values, you get the equation of the axis of symmetry, and that gives us the x coordinate of the vertex. How could you use 2 points on one horizontal line to find the vertex? Okay, so what do we know now? We know the x coordinate of the vertex. What do we do with it? Well, now we're going to plug it back into the equation, right? So I want to know what's the y coordinate of the point what's the y coordinate, right? So the x coordinate of the vertex is on the axis of symmetry. Okay, so number 1. Okay, again, just pretend we're doing this from scratch. You see table of values, you look and you say, hey, look, -5, 3, and 0, 3, right? They have the same they have the same y coordinates, okay? So I'm going to average them together, which will give me the equation of the axis of symmetry, but that gives me the x coordinate. So the x coordinate of the vertex, coordinate of the vertex, is on the axis of symmetry. Okay, C5b. We're going to substitute the x value from the vertex into the equation. Okay, so step 2, substitute the x coordinate of the vertex into the equation y equals ax squared plus bx plus c. To find the y coordinate. All right, find the vertex of the parabola above using 2 points on a horizontal line passing through the parabola. Okay, so it's just going to become a more general question. We've already done part of it. Okay, but find the x coordinate. Okay, so number 1, we know the x. We know the axis of symmetry. Axis of symmetry is x equals negative 2.5 from 5b. Okay, so if you haven't done it, if it's a brand new question, you haven't done that already, you're just going to look for where are two y values the same. I'm going to average the x values. Okay, gives me the x coordinate. And then, number 2, we're going to substitute negative 2.5 for x in the equation y is equal to x squared plus 5x plus 3. Okay, so that's going to be y is equal to negative 2.5 squared plus 5 times negative 2.5 plus 3. Negative 2.5 squared is 6.25. 5 times negative 2.5 is minus 12. 12.5 plus 3. So that's going to give me negative 6.25 plus 3 is negative 3.25. So the vertex is at negative 2.5, negative 3.25. All right, give you a chance to copy that down, think about it, make sure it makes sense. Make sense? Okay. It's a little while, it's gonna be homework time. You got to practice this, right? Otherwise, you're sitting on the test looking and saying, "Would it look easy when he did it?" But I don't know what to do now, right? So just make sure you do enough of these. State the domain and range for the parabola above. Okay, so if we went back in here and we said this is here's my vertex at negative 2.5, negative 3.25. It looks like this. Okay, so what can we say about the domain of every parabola ever? Element of the rails. And for this guy, what can we say about the range? Okay, it opens up, so it's greater than or equal to the y coordinate of the vertex, right? Greater than or equal to negative 3.25. Okay, any questions? All right, let's do a few examples. Examples involving quadratic function. A parabola passes through the points 1, 9, and 5, 9. Determine the equation of the axis of symmetry for the parabola. Okay, what do we have to do? What do we have to do? What's the answer? We got an answer? Blurt out an answer. 17. Wrong. Yep. Yep. Okay, so think about it. If it helps you, draw a little picture, right? It's not going to hurt if you want to draw a little picture. You just say, okay, a parabola goes through 1, 9, and 5, 9. Right? So there's my 2 points. Right? That's 1, that's 5, that's 9. Does this parabola open up or down? How do you know? You don't know. It doesn't matter. Okay. Does it open up or down? The answer is yes. It does. It opens one of those. We don't know which one. Does it matter? It doesn't matter. So just draw it like this, and say, okay, look, there's a parabola. Here's my axis of symmetry. Okay, what is it? You should just be able to tell me. What is it? X is equal to
3.
3. right? What's halfway between 1 and 5 is 3, right? Okay, but we're doing this a little more formally, right? So if you need to, you just draw a little sketch to remind you that, okay, if I have these 2 points, right, and they're on a parabola, 2 points, so I just draw a parabola, that the axis of symmetry is halfway between them. Okay, so you're going to say, all right, I'm going to go halfway between them, so the axis of symmetry. A of S is halfway between these 2 points. These 2 points. Since they have the same y coordinate, right? Since they have the same y coordinate. Of 9. Okay, so that's the first proviso, right? They have to have the same y coordinate. If they do, then they're on a horizontal line. If they're on a horizontal line, then the axis of symmetry lies halfway between them. Okay, so then what we want to do is just find the average, right? So 1 plus 5 over 2, 6 over 2 is equal to 3. Now it says the equation of the axis of symmetry, so what am I going to write? Bless you. The equation of the axis of symmetry is? Don't blow it now. Get that last half mark. This close. It's the equation of the axis of symmetry. Yeah. X equals 3. Okay, remember, it's an equation, so it's got to have an equal sign, right? That's what equations do. They have equal signs. It's a line, right? The axis of symmetry is a line. So it's either y equals or x equals, but it's a vertical line, right? What can we say about this vertical line? Right? It's just x equals 3. Okay. A parabola has x-intercepts at negative 2.6 and 5.8. Determine the equation of the axis of symmetry. Okay, what do we do? Average those two numbers. How do you know they're on a horizontal line? They're x-intercepts, right? So if it helps you, draw a picture, right? It's not going to hurt. So I got a parabola. What do we got? Got an x-intercept here at negative 2.6. Got an x-intercept here at 5.8. Okay, last parabola opened up. This one's going to open down just to give equal time to both sides, right? We can't be seen to favor opening up over and opening down. Parabola doesn't matter, right? What do you know about those 2 points? Hey, you see, they're on a horizontal line, right? Okay, so what do I do? Average them. What's that going to be? 3.2, which is 1.6. Okay, and then how do we end it? Okay, with the equation. Don't get the 1.6 and say, I don't need that extra half mark. Right? That's for chumps. So people who want to do well in this course, half marks. I'm going to give them up. Each question I will lose like a. You don't want to do that, right? So x equals 1.6. Okay? You want, think about it, right? This is the point, negative 2.60. This is the point, 5.80. Right? X-intercept occurs when y is equal to 0. So if you need to, turn it into the 2 points, negative 2.60, 5.80. Me, I like drawing a picture. Okay? I like to visualize it. What does that look like? Oh yeah, they're on a horizontal line there. Okay, good. Using a GDC, which is a graphing display calculator, using your graphing calculator. For applications of quadratic functions, okay? So things change a little bit here, right? There becomes context comes into this situation. that may change our domain and our range, right? Because now we're dealing with something real. So, volleyball is bumped off the arms of a player and is passed to another player. The ball hits the hands of the second player at a height of 6.5 feet. The height of the ball between the first player and the second player as it relates to time, it's an angle, in the air is given by the equation h of t is negative 6t squared plus 12t plus 2. Graph the equation with the graphing calculator using an appropriate window and sketch the graph below, labeling the axis and the important points of the graph, which include the y-intercept, vertex, and sometimes x-intercepts. Okay, so x-intercepts if they matter. Okay, so graphing display calculator out, on, move this over so I get the equation. Okay, turn that on. Turn that on. Pause. 46 minutes into it. Okay, so I'm just going to edit what I already have here, right, because I am lazy. Negative 6x squared plus 12t. So I got a plus. Okay, I'm just going to retype the rest of it. Plus 12x plus 2. Now, if you're typing over a line that's already there, just make sure that you don't. I don't know if I need this y2 equals 0, so for now I'm going to clear it. I'm going to go zoom 6. Just do a standard window, right? So what does this thing look like? Okay, so, ball second player, so, what's the situation? Bumped off the arms of the player passed and the ball hits the hands of the second player at a height of 6.5 feet. The height of the ball between the first player and the second player is there. Okay, so somebody's hitting the ball, they're bumping the ball. So they bump the ball at time 0, right? That's when so whatever height it's at time 0, that's where they bumped it, okay? And then it goes up in the air, right? We've all seen volleyballs, right? So it goes up in the air in an arc, right? An arc, it's a parabola. It goes up in the air in a parabolic arc. It's not only an arc, it's a parabolic arc. And then hits the hands of the second player at a height of 6.5 feet. Okay, and this equation gives us the time between the bump at time 0 and the time that it hits at 6.5 feet. Graph the equation with use the appropriate note. Sketch the graph below, labeling the axis and important values. Okay, so here's our graph. So we want to go from time 0, so I don't care about anything out here. 6.5 feet, so 1, 2, 3, 4, 5, 6. So we're going to assume that hits the hands of the second player, height of 6.5 feet. Now, I guess an interesting question here is, did it go up all the way and then come back down to 6.5 feet? Or did they get it? Probably it's coming back down to them, right? I mean, usually if it's still going up, you can't really do too much to it because if you jump forward, it's still going up. So you're waiting until it's coming back down towards you. So this is like 1, 2, 3, 4, 5, 6.5 feet. It's going to be in there. So about 2 seconds, right? It's going to be about 2. So, okay. And actually, a little bit over 2 seconds, sorry, it would have hit the ground if it hadn't hit that player. Okay? So, we're going to go 0 to 2 and 0 to 10. So I'm going to set my window to say, okay, starts at time 0 seconds, goes to time of 2 seconds. 1 is fine there. Starts at 0, goes to 10. Okay, what do we got? Okay, so that's a little better, right? Nicely fills the grid. Okay, so graph this equation with an appropriate window. So this is our graph. Looks like that. What are we saying? Our x values were 0 to 2, and our y values 0 to 10. Important points. Y-intercept, vertex, x-intercepts. Okay, so what's the y-intercept? Well, we can just get that from here, right? The y-intercept is 2. 2. You want the y-intercept off of here, you just go second calc, value 0, x equals 0, you get 2. Okay, and then you realize, I could just look at the equation, right? Save myself some time. It's 2. What's the vertex? So what's the maximum height? So second calc, it's going to be a maximum, right? Vertex maximum. Oh look, it's locked on. Stop. Enter. Exit. Pause one more time. Okay, anyways, you guys. Oh, great. I just turned off. Okay. What?
I got Vertex.
Yeah, what's the vertex?
X1 and Y8.
1, comma 8. Okay. And we got this X-intercept here. I'm going to retype this, I guess. What? I'm going to go to 3. Okay. A second calc. Whoops. I'm going to go for 0 this time. We'll just do this 0 down here. Come on. So left bound is just going to be above the axis. Right bound is just going to be below. I just need this to get negative. 2.15. So. Okay. Is that important? No, not really, but it could have been, so it doesn't hurt for us to be able to find it. Okay, so we got the y-intercept, we got the vertex, we have that one x-intercept. Okay, how high is the ball when it is bumped by the player? Okay, wait, so that's our graph. Let's look at our actual context here, right? Our context is this, where this is, what did we say, 6.5 feet. Okay, so that's 1/8, that's 2, and that is something, comma, 6.5. Okay, so this is actually what the ball is doing, right? It's bumped, it goes up, it comes back down. This is where the second player gets their hands on it. Okay, at that point, it doesn't do this, right? It's not falling to the ground. Okay, it's going to be stopped and probably set or whatever. Okay, anyway. How high is it when it's bumped by the first player? This is the y-intercept. That time plus you, 0 seconds. Okay, so it's 2 feet. You can go second calc, value, put in an x value of 0, right? Or you can look at the equation. What is the maximum height of the ball and when does it occur? So that's the vertex, right? This is the vertex. So it reaches a maximum height of 8 feet at a time of 1 second. So it reaches a maximum height of 8 feet at time 1 second. So it's 1, 8, it's x, y, and it's time, comma, height. Right? So the x is time, and the y is height. Right? So the vertex is at 1, 8. That's an x, y. X is 1, y is 8. But x is time, and y is height. When does the ball reach the hands of the second player?
Approximately 1.5 seconds.
1.5 seconds? Okay, how are we going to get that on the calculator? So we got to go to y equals.
And the second y equals 6.5, and then you calculate the intercept from there.
Okay, so we need to graph a y value. So if I wanted the height at a time of 0, I just use second calc and I put in an x value, right? If I knew this was at 1 second, I could go second calc and put in a 1. If you say, how high is the ball after 0.5 seconds, then I would go second calc and put in a value, an x value, right? Because if you said after 0.5 seconds, I'd put in an x value, 0.5. It happens to be at 6.5. That was just randomly weird. I didn't plan it that way. But I want to know how high is it, or sorry, I want to know what's the time when it reaches a height of 6 seconds. So for that, we have to graph y2 as the height, and we have to move and do an intercept. Be careful not to toggle the button on. Okay, and the way I do an intercept is, of course, have the two curves, go to the point of intersection, and then hit enter 3 times. The lazy person there. Okay, 1.5 seconds. Okay, when does the ball reach the hands of the second player?
1.5 seconds.
So y2 is equal to 6.5. Second calc intercept. Okay, and you get x equals 1.5. So the ball reaches the hands of the second player. At a time of 1.5 seconds. Okay, so for those new and not so new, so the questions, green sheet. So green sheet, Monday, February 6th, right? Telling us what we've learned today. So properties, the vertex, direction of opening, axis of symmetry, maximum or minimum values in domain and range. So for us, this question really has a domain of x goes from 0 to 1.5 seconds. And it really has a range of from 2 feet to 8 feet. Right? Because that'll enclose the values that we want with the context of the question. So anyway, 6.2, page 332, numbers 1, 2, blah, 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 right? It's on the green sheet. Okay, and then tomorrow is what? Tuesday is factoring, defining X-intercepts, etc., right? So remember factoring from grade 10. If not, you might want to